Hello everyone, I'm Giacomo Molilla, Senior Solution Architect in AWS for Energy, and in this session I'm going to demonstrate how enterprise organizations can leverage VPC Lattice to securely interconnect applications across VPCs and accounts. In this session I'm going to guide you through the typical challenges in interconnecting modern applications, especially as organizations embark in a modernization journey from monolith to microservices. I'm going to introduce VPC Lattice and show what value brings to AWS customers. I'm going to dive deeper on how it works and what are the key components of VPC Lattice and show common use cases you can address with the service. Let's talk about a monolith to microservice journey. When customers modernize, they enjoy the fullest benefit of the cloud, maximizing agility while minimizing operational load. Modern applications can be characterized along five vectors: their architectural patterns, developer agility, data strategy, operational model, and management and governance. Customers who are in the app modernization journey from monolithic application to microservices already understand the benefit. They are, however, also looking for additional flexibility and operational efficiency from creation to operation of microservices. Customer wants flexibility in compute choices, observability and traffic control, higher developer productivity, zero trust architectures across services, resilient and low-cost operations, scalability, high availability, and failover. If you would like to connect two applications running on two different VPCs and managed by two different teams, there are existing solutions available, both as open source solutions and as commercial products. However, they have the following drawbacks. For what concerns the data plane, it is hard to maintain and need to handle patch against zero-day vulnerability. Connecting serverless services can be very complex, as create proxies requires end-to-end testing, and complex inter-VPC networks slow down developers. Instead, for what concerns the control plane, consistent traffic and access policies are hard to enforce. You need to handle scale and high availability. Complex inter-VPC networking is difficult when dealing with multiple accounts and VPCs. When looking at the personas within an organization, we typically see the following challenges. As a developer or service owner, you have to deal with subnet and route tables across VPCs. Troubleshooting and optimization are complex. You spend time away from writing business logic. As cloud or network admin, you have no central tool to enforce access control and security posture. Lack of observability into developer system, and you have a risk of large blast radius across VPCs and accounts. You have a loss of control with inconsistent developer environments. So what if we have a solution which doesn't require any proxy or data plane, and where the control plane is fully managed with scale and high availability built in? It provides a single policy engine across services, VPCs, and accounts. It provides as well control for cloud admins with agility for developers. It helps in reducing blast radius for faster troubleshooting. With this, I'm pleased to announce and introduce Amazon VPC Lattice, which is generally available since March 31st. Built for developers, but with the tools and controls admins required to audit and enforce. VPC Lattice provides connectivity, so you are able to find and connect services across accounts and VPCs. It supports application-aware routing, and it supports overlapping siloed blocks across VPCs. It is allowed with IPv4 and v6 in a mix and match fashion. It provides consistency across compute services as it integrates with EC2, ECS, Lambda, and EKS to provide a consistent experience across instances, containers, and serverless. It provides observability and traffic control. It is easy to export logs and metrics to S3, to CloudWatch, and to Kinesis. It provides advanced Layer 7 routing and resiliency controls. Load balancing included, so you don't need any more ALBs or NLBs for east-west traffic. It provides security. App identity is based on IAM rules, which are not dependent on layer 3 or 4. Simplified access policy for zero trust architecture with IAM, and centralized log controls of ingress and egress. Amazon Lattice provides application communication across accounts and VPCs with no proxies to deploy and maintain. It allows to connect to serverless services easily. Developers can focus on business logic versus networking. The control plane is fully managed with scale and high availability. VPC Lattice provides single policy engine across services, VPCs, and accounts. So it combines control for cloud admins with agility for developers. VPC Lattice brings the following benefit. You can secure your traffic, connect your VPCs to services in AWS in a secure and scalable manner with AWS Private Link. Network traffic that uses AWS Private Link doesn't traverse the public internet, reducing the exposure to threat vectors such as brute force and distributed denial of service attacks. Simplify the network management. You can connect services across different accounts and Amazon VPCs with no need for firewall rules. With Private Link, customers don't have to worry about managing the IP addresses space. We have customers who stamp out hundreds of VPCs with same overlapping IP address ranges, and that is a huge simplification for them. Accelerate your migration. More easily migrate traditional on-premises application to SaaS offerings hosted in the cloud with AWS Private Link, since your data does not get exposed to the internet, where it can be compromised. You can migrate and use more cloud services with the confidence that your traffic remains secure. Reduce cost. Private Link can help customers reduce costs, especially when they are accessing services over the internet behind a NAT device. Earn trust by reducing cost. Eliminates unnecessary ingress costs for data transfer out of the AWS network, including for AWS partners. Now, let's see how Amazon VPC Lattice works. There are 4 key features in VPC Lattice: services, service network, health policies, and service discovery. A service is a unit of application. It can be built on any compute and can live in any VPC or account. It consists of listeners, rules, and target groups. This is very familiar with AWS Application Load Balancer. You can group these services in what we call a service network to apply common connectivity, monitoring, and access controls. You can think of this as a new way to create an application layer boundary to complement your existing network and permission boundaries with VPCs and accounts. You can share service networks and services across accounts with Resource Access Manager. This lets you create a boundary that actually maps to how your applications are deployed. Health policies is how you enforce authentication and authorization. It is basically an IAM resource policy where the resources are your services. Health policies can be applied at both service network and the service, giving admins a central place to enforce coarse-grained guidelines like only allow authenticator requests from my org ID, but at service level, do something more fine-grained, like only allow GET requests from account 123 from a specific principal. And the service directory. This is an account level view of all the services you created or were shared with you via Resource Access Manager. Developer can jump into the console, find the service they are looking for, copy the DNS name, and get going. This also gives admin a really easy way to audit the services a specific account has access to. As an admin, you will be the one who creates the service network and applies access controls on the service network. You can also enable logs with a single API call for all the services in a service network. You are the one who enables connectivity by associating the service network with VPCs. And if you are dealing with multiple accounts, you can share this with your organization or individual accounts through Resources Access Manager. As a developer or service owner, you will be the one that creates the service. You can also apply access controls and choose how you want your metrics and logs delivered via CloudWatch, S3, and Kinesis data firewalls. If you need to perform any advanced request level routing for HTTP and gRPC requests, you can configure listener, rules, and target groups, similar to an application load balancer. And lastly, once you have created your service, you can associate it with one or more service network. Something for everyone. This keeps the admins in control and provides a simple but flexible onboarding experience for the service owner or developer. The admin can enforce their security guardrails, and the developer can use whatever compute platform makes the most sense for their workload. They can also configure additional security policies or advanced traffic management if this is needed. And both of them can enable rich metrics and logs so they can understand their usage patterns and assist in those late night troubleshooting sessions that used to involve a lot of finger pointing. Each VPC can be associated with a single service network. This is basically the way you scope down the services you want to share with a given VPC. You can also associate the same service network to many VPCs, which makes sharing services for common dependencies really easy. Services that can associate with many service networks. This gives a lot of flexibility when dealing with shared services that require unique access requirements per VPC. There have been small attempts at solving these problems, for example with containers or service mesh. Service mesh requires things like sidecars that came with a lot of management overhead and don't work well across VPCs or accounts. We need to solve this in a way that works from startups to the largest enterprises, with the most stringent network controls and security. When working with EKS, Lattice implements Kubernetes Gateway API spec, while service discovery is done using DNS. When working with ECS, you attach a service in ECS task to Lattice service network using an ALB, while service discovery is still done with DNS. Deeper integration with ECS is on the roadmap. When working with serverless, so with Lambda, you attach a service running in Lambda to a Lattice service network, and service discovery is still done with DNS. Now, going a bit deeper into Kubernetes, the Kubernetes Gateway API is designed to be generic, expressive, extensible, and role-oriented. For this reason, we chose to integrate with the Kubernetes native Gateway API to provide the same level of abstraction for Kubernetes users that is both flexible and portable. We have built an AWS Gateway API controller that allows customers to configure their Kubernetes services and define advanced traffic management through the Gateway API. Behind the scene, The AWS Gateway API controller will set up VPC Lattice and enable multi-cluster connectivity, even across VPCs, without touching a single VPC route table. For those of you that may not be familiar with the Gateway API, it's basically an evolution of the Ingress API, but provides a lot of more advanced features that were not possible before. In this slide, you can see the mapping between VPC Lattice and the Kubernetes Gateway API, where the service network maps to the Kubernetes Gateway API, the service maps to the Kubernetes HTTP route API, the target group maps to the Kubernetes Service API, and the target maps to the Kubernetes Pod API. Kubernetes users can pick and choose which services in their cluster they want to share and how they want to handle load balancing the traffic between different versions and cluster, and VPC Lattice does the rest. VPC Lattice provides network connectivity, service discovery, load balancing and traffic management, authentication authorization, and observability. Since Lattice is built directly into the VPC infrastructure and doesn't require you to run any additional software in user space, it works across any underlying compute in AWS, EC2, containers, and serverless. Let's see some use cases for Amazon VPC Lattice. Using VPC Lattice, you can connect services across VPCs. Underneath the hoods, it uses AWS private link, which uses either plain-to-link interface and point to the NLB. It eliminates the need for complex network address translations, VPNs, proxy devices, but can still operate across VPC that have overlapping IP spaces. VPC Lattice allows AWS customers to do traffic shaping by doing load balancing, weight target, service discovery via DNS, health checks, retries, timeouts. It provides routing controls, supporting HTTP, gRPC protocols, and TCP support is on the roadmap. It supports path-based, host-based, header-based, and method-based routing. When working with software upgrades, VPC Lattice facilitates the implementation of canary and blue-green deployments by providing a weighted routing mechanism. For example, you can route 90% of your traffic with your old version of the application and only 10% of the traffic to the new version of your application. Path-based routing, it is supported, so you can route, for example, API/parking to a service and API/inventory to a different service. As well, it supports host-based routing, so you can route parking.hotel.com to a set of services, while inventory.hotel.com to a different set of services. With VPC Lattice, you get visibility into your workloads as it provides logging, so you get visibility into your HTTP access logs. It integrates out of the box with Amazon CloudWatch logs. It is available as container logs on Amazon ECS, EKS, and Fargate, as well as integrates with AWS Lambda logs. It integrates with the CloudWatch metrics and with AWS X-Ray for tracing. To summarize, VPC Lattice helps you connect, secure, and observe your service-to-service communication across VPCs, accounts, in a consistent way across instances, containers, and serverless computer. It is not just simple networking level connectivity, it is a full-blown application layer proxy that handles service discovery, authentication, authorization, and rich traffic control to remove the need to deploy and manage your own service mesh or sidecar proxies. And now I'm going to show a quick demo on VPC Lattice integrated with EKS. Here I'm on the console of AWS and I'm on the VPC Lattice section, which is under the VPC service. Here I have my service network, which I have already built, and I have my service, and I have two target groups. Now I'm going to switch a different view and show you how this is set up. Now in this account, I have two different EKS clusters. So I have this cluster 1, which is identified as EKS Workshop VPC1, and I have this second cluster, which is identified as EKS Workshop VPC2, and the two of them live in two different VPCs. Now, in the first cluster, I am going to show I have an application called frontend, which is running in one pod. I have a service that exposes the application to a load balancer, and this is the endpoint. And this is the deployment controlling my pod. In the second cluster, instead, I have my backend. So I have an application called data store. In fact, I have two. I have a version 1 and version 2. Both of them are running in a single pod. In the same VPC, I have a database where this data store connects to. So in my VPC2 cluster, I have a gateway. And now this gateway, you can see that defines the Amazon VPC Lattice. It uses the Amazon VPC Lattice gateway class name that is linked to the EKS Lattice network that I showed previously in the AWS console. In this cluster, I also have an HTTP route. The HTTP route is the object that is used within EKS to define the services. In this, you can see that I have two different services. I have one that responds and I'm doing path-based routing. So everything that starts with the path /prover goes to the V1 service. And then I have a /summary path where I'm doing a weighted routing where 50% of the requests will go into the data store V1 services and 50% will go into the data store V2 services. With this, I'm going to show you quickly a demo. So I'm going to connect to the front-end application. This is the same endpoint that was shown before when I looked at the first cluster. This will connect into the back-end application, which will connect to the database. Even though the two clusters are on two different VPCs and there is no network connectivity in place. So with this request, I can see that it responds from the version 1 of the service and gives some data back. Now if I clear this and run from the summary, I'll have that this responds again from the V1. It responds from the /summary and there is no data. Now I'm going to run it again and I'm still getting from V1. If I run it again, this time I got it from the V2 instead. And so the version here is 2.0 and I've got some data. This is to demonstrate how the weighted traffic works. So it handles 50% of the request goes into the V1, 50% of the request goes into the V2. And with this demo, this is all. Thank you for watching. I hope you enjoyed this video.